Hello. In the polar coordinate system, each point is represented by two coordinates, r and theta. R is the directed distance from the pole, and it can be positive, negative, or 0. Theta is the angle generated by rotation from the polar axis. It can be measured in degrees or in radians, and just like r, it can be positive, negative, or 0. To plot a point in the polar coordinate system, we start by drawing angle theta. If this angle is positive, then from the polar axis we move counterclockwise, but if it's negative, we move clockwise. Once we have the angle, if r is positive, then starting from the pole, along the terminal side we count r units and we plot the point. But if r is negative, then we need to extend this terminal side into the opposite direction of the pole, and on this opposite side count r units and plot the point. In this video, I want to show you that in the polar coordinate system, each point has infinitely many representations. In this example, we have multiple polar coordinates, and you will see that each one represents the same point. To the right, we have the polar coordinate grid that will allow us to accurately draw the angle and count the number of units from the pole. First, we will plot the point 4, 60 degrees. We will start by drawing the angle of 60 degrees, and because this is a positive angle, from the polar axis we will move counterclockwise. And now, along the terminal side, from the pole, we will count 4 units, 1, 2, 3, 4, and we will plot the point. Next, we will plot the point 420 degrees. Notice that this angle is more than one full revolution. To draw this angle, first we will write it as a sum of 360 degrees, which is one full revolution, plus another 60 degrees. So now, from the polar axis, we go one full revolution of 360 degrees and another 60 degrees. So now we have the same terminal side, and if from the pole we count 4 units, we get the same point. Next, we will plot 4 and negative 300 degrees. This is a negative angle, and to draw it, we need to move clockwise. So if from the polar axis we move clockwise and we draw the angle of 300 degrees, then this will be the terminal side. And again, if we count 4 units, we get the same point. Next, we will plot negative 4, 240 degrees. So this angle is positive, therefore we will move counterclockwise, and here we will have the terminal side. However, r is negative, and this means that the point will not be located on the terminal side. Instead, we have to extend this line into the opposite direction of the pole, and then on this opposite side count 4 units and plot the point. Next, we will plot negative 4, 600 degrees. This is another angle that is more than one full revolution. We can write it as a sum of 360 degrees and another 240 degrees. So we will go around one full revolution plus another 240 degrees. So this is the terminal side, but because r is negative, the point will not be located on the terminal side. Instead, we need to move into the opposite direction from the pole, count 4 units, and plot the point. And now the last point we will plot will be negative 4, negative 120 degrees. As you see, this is a negative angle, so from the polar axis we move clockwise 120 degrees. And again, this is the terminal side, but because r is negative, we move into the opposite direction, we count 4 units, and we plot the point. So you see in this example that all these coordinates represent the same point. So in general, let's say we have a point with the coordinates r and theta. One method of finding more representations for this point is to keep r the same, then to theta add or subtract 360 degrees as many times as we want. So again, keep r the same, and then to theta add or subtract 360 degrees as many times as we need. So the new angle is theta plus 360 multiplied by n, where n is an integer. And this is exactly what we had in these two examples. So if r and theta are 4 and 60 degrees, then in the second example r stays the same, but now the angle is 60 degrees plus another 360 degrees. And we can also say that in that example n is 1, and that means that we have one full rotation. Now in the next example r is still 4, but now the angle of negative 300 degrees is the initial angle of 60 degrees plus 360 degrees multiplied by negative 1. So in this case n is negative 1. And as you see, 360 times negative 1 is negative 360 plus 60 is negative 300. Now in radians, this formula is r, theta equals r, and theta plus 2 pi n. So 2 pi in radians is the same as 360 degrees. Now let's see another method of finding more representations for the same point r and theta. So again, here we have r and theta, but now we will change r to negative r. Then to theta, first we will add 180 degrees. So for example, if angle theta is 60 degrees, then if we add 180 degrees, then this is going to be the terminal side. Then from here we can add or subtract 360 degrees as many times as we would like. So in this formula we will add 360 degrees multiplied by n, where n is an integer. And this is exactly what we have in these three examples. If initially r was positive 4, in all three examples now r is negative 4. So here we have negative 4, and 240 degrees is 60 degrees plus another 180 degrees. In the next example, again r changes to negative 4, and then 600 degrees is 60 degrees plus 180 degrees and plus one full revolution of 360 degrees. So again, in this case, we can say that n is 1. And now in the last example, r is negative 4, and then negative 120 degrees is 60 degrees plus 180 degrees, and then plus 360 degrees multiplied by negative 1. As you see, in this case, n is negative 1. If we look at the grid, that's going to be 60 degrees, another 180 degrees, and then going into clockwise rotation, 360 degrees. Now in radians, this formula is r, theta equals negative r, and then theta plus pi plus 2 pi times n. So pi radians is the same as 180 degrees, and 2 pi radians is the same as 360 degrees. So using these formulas, we can get infinitely many representations of the same point. Thank you for watching.